When you're trying to predict the products and your list of problems is mixed, my suggestion is that you run through the list and you try to identify the type of reaction each problem is. So when we look at silver plus copper 2 sulfate, we see that we have a single element plus a compound. This is a single replacement reaction. The second problem, sodium iodide plus calcium chloride, has 2 compounds. This is going to be a double replacement reaction. For that third problem, we have 1 compound on the left side of the arrow. The only possibility is for it to break apart, and that will then be a decomposition. And the last one is the one that students most often miss, because what they see is they see a compound and a single element, and they want to call this a single replacement reaction. But if you look at it a little bit closer, you'll notice that we have carbon, hydrogen, and oxygen, which makes this one a combustion reaction. Once you've identified the type of problem, you can go ahead and try to predict the products. So we know for a single replacement, we need to identify the charge on our ions. And you'll notice that because copper is a transition metal, it would be a good idea to identify the charge on it, which is a +2, only because the sulfate ion in this case has a -2 charge. We are going to trade places with our 2 positive ions. Silver is going to partner up with SO4. Copper will be left alone. Let's create a neutral compound. Silver has a +1. Sulfate has a -2. When I crisscross my charges, I end up with Ag2SO4. The second question you need to ask yourself with a single replacement is my single element a diatomic element? In this case, copper is not diatomic, so we can leave it alone. Our second problem is a double replacement. We're going to go ahead and switch our 2 positive ions. Calcium will partner up with iodine, and sodium will partner up with chlorine. And then we want to look at our charges. So calcium has a +2 charge, iodine is a -1 charge. In order for that to become a neutral compound, I crisscross my charges and I have CaI2. Sodium has a +1 charge, chlorine has a -1 charge, so that compound, sodium chloride, is already neutral. For our third problem, sodium oxide, it's decomposition, so I'm going to break it into its 2 components, which is sodium and oxygen. And then I need to look at both of those elements and ask if either of them are diatomic. Sodium is not, so it is fine as it is. We do not put a subscript on sodium. Oxygen is a diatomic, so I'm going to put a subscript of 2 on my oxygen. And then finally, for the last problem, combustion, there's really no work here because the products for combustion are always CO2 plus H2O. At this point, you want to go back and you want to make sure that all of your problems are balanced, and then you're good to go.